Hello for another nice evening with Kea DHCP. I'm Karsten, and today I'm talking about migrating to Kea DHCP. So this is about moving from whatever DHCP server and service there is currently to Kea DHCP. Of course, we mostly look at ISC DHCP, which is the older now end-of-life version of the DHCP server from ISC, but most of the stuff we are talking about today also applies to other DHCP servers, maybe open source or commercial ones. So we talk about getting to know your existing DHCP implementation, and then some ideas to defragment your network. We talk about the choices we have now with Kea High Availability, and the steps to plan a migration towards Kea DHCP, and step-by-step migrations that I've used in the past and worked for me, and maybe they work for you as well. This is not the first webinar on the topic. We had 2 years ago a webinar already where we covered more the technical part of doing a migration. There, we talked in detail about the Kea Migration Assistant and other tools that can be used to move from ISC DHCP to Kea. Today, in this webinar, we take a more high-level approach. We more look from the process point of view and how to approach such a migration. Other webinars from this series might also be interesting. For example, in the webinar on configuring vendor options, we discussed how we can migrate custom vendor options from ISC DHCP to Kea DHCP. So often DHCP environments that we see today in enterprise or university environments or large telecommunication environments are grown over many, many years. Some are even 30 years old. Now, over that time, a lot of craft has been accumulated, and not all of that implementation of DHCP has been documented. So it's good to know about the network, and to make sure that you know what is in your network. Also, the older DHCP servers that you are now using or might be now using, might it be ISC DHCP or some other DHCP service, is probably very different from Kea DHCP. So migrating towards Kea DHCP often requires changes in the way the DHCP server is being configured and run. On the next slide, I will give a high-level overview of the functions, and you will see that there are a couple of differences between ISC DHCP and Kea DHCP. First, ISC DHCP. So we have clients, and that client send DHCP requests mostly through a DHCP agent. And that DHCP agent then forwards the DHCP request to the ISC DHCP server. In ISC DHCP, the admin can control the ISC DHCP server through the OMAPI interface, which is kind of an API where over the network you can talk to the ISC DHCP server and make certain changes to the running server. The other option is to change the configuration file and restart the ISC DHCP server service process. Also, ISC DHCP has the ability to dynamically update the DNS servers with the pointer records and A records or quad A records. And that's mostly about it, what we can do with ISC DHCP. If we compare that, one more, of course, we can do high availability with ISC DHCP. So we can have a cluster of 2 ISC DHCP servers, and they provide a redundant service for the DHCP. If we compare that with Kea DHCP, we see there are much more options. Most of these options are, because they are options, are optional. So you don't need to deploy them, but you have the ability to do that if you would like to use that functionality. We still have the client sending DHCP requests to a relay agent, and that relay agent is forwarding the DHCP request to the Kea DHCP server. That's the same as with ISC DHCP. Kea DHCP can also update the DNS servers for the A and Quad A and pointer records. The administrator now has a rich RESTful API, and that's much, much nicer than the OMAPI interface. And it also covers more functionality that we can use in the Kea DHCP server. And there's also Stork, and Stork provides a web UI and also additional API functions where we can use Stork to manage one or more Kea DHCP servers. Also, Stork provides monitoring through a Prometheus exporter. So Prometheus monitoring system or something that talks the same Prometheus protocol language, which is basically just a simple text file over HTTP, can make use of this monitoring interface. Kea can store data in SQL databases, and we have the choice of either using MySQL or PostgreSQL. Kea can store the leases, reservation data, or even complete configurations in databases. Again, that's optional, doesn't need to store that in an SQL database. You can just happily run a Kea DHCP server without any SQL databases, but the option is there if you like that. Kea can talk to a radius server to authenticate DHCP requests. And of course, we can have high availability with Kea. And there we have multiple options. We can have a load balancing high availability system where both Kea instances are active at the same time. We also can have backup servers, any number of them. And these backup servers, they receive updates, lease updates, and they can be put in place whenever one of the active servers die. The benefit of having these backup instances is that they can be really far away network-wise. So they don't need to be in the same data center nearby the active Kea DHCP servers. We also can have a hot standby high availability, where one Kea instance is the active one, and the other one is the hot standby, which detects automatically if the active one is not available anymore and will then 100% take over the service. So I found that a very important factor of successful migration is to have a good understanding of the existing ISC DHCP configuration. And unfortunately, what I've seen in networks that run DHCP for multiple years, that knowledge about how the existing DHCP configuration really, really works has been lost in time. So before attempting a migration to Kea DHCP, it's a good idea to go through the existing system and update the documentation. Also challenge the knowledge and the assumptions you have about the current DHCP servers. Try to test out your assumptions and make sure that you have proven that the assumptions are correct. So this is what should be ideally be in a documentation of a DHCP server. That documentation should list the subnets and the subnets configurations. Of course, if there are hundreds or even thousands of subnets that share the same identical configuration. It's not needed to have them all in the documentation, but have one fully documented and then list the IP addresses of all the other subnets referencing the one that is being documented. Same is true for shared networks and reservations. Again, with reservations, no need to have every single reservation in the documentation, but every different kind of class of reservations that are in the configuration. Client classes are a very special thing because they can be very specific to the network. And so it's very important to have them documented. Also, there are slight differences between client classing in ISC DHCP and Kea DHCP. So having a good understanding on how client classing works in both ISC DHCP and Kea DHCP helps to create a successful migration. And then the DHCP options, the base parameters being the lease time, renew timers, and so on. Also documenting the relay agent configuration on the routers. And if the current system has some failover or high availability, document that as well. The configuration file format, the configuration language of ISC DHCP is like a programming language. That makes it very, very flexible in processing the DHCP request. You can have conditional statements, assignment of options based on some parameters of the request, and you can even rewrite parts of the DHCP packet on the fly. But that flexibility comes with a price. ISC DHCP is slow, and one reason why it is slow, it is because of that flexible programming language or configuration file that is almost a programming language. Kea DHCP works differently for performance reasons and also other reasons, and the configuration format is completely different. However, you can implement most of the functionality that there is in ISC DHCP also in Kea DHCP. You can either do that with the built-in DHCP features of Kea, or you can use external hooks that augment Kea DHCP with new functionalities. I would highly recommend to have some kind of a test laboratory test network where you can test out your new configurations, where you have one or more Kea DHCP servers installed and a couple of normal client systems and DHCP relay agents, where you can test drive your new configuration before you try that out in production. And if you currently don't have any monitoring on your DHCP server, and surprisingly, a lot of networks don't have monitoring on DHCP. They have monitoring on almost everything else, but not on the DHCP servers. It's a good idea to implement that monitoring before starting the migration, because then the monitoring supports you during the migration. The monitoring tells you early if something is wrong while you do the migration. In the resources chapter we have later in this webinar, we have some links on monitoring tools that you can use with both ISC DHCP and Kea DHCP. ISC likes to have feedback from its users, and this feedback usually makes the products much better. And that includes feedback on Kea DHCP and the migration tools provided. If you have a test lab, you can help, or that can help to identify any issues in an early stage of migration. And in an early stage, ISC can maybe help you in mitigating that issues. This might be because there is a shortcoming in Kea DHCP that can be implemented, or maybe a new feature that is missing, or occasionally there might even be a bug in Kea DHCP that can be fixed. So don't hesitate to get in contact. There's the ISC mailing list, And even if you don't have a question, but if you have some experiences in your migration, something that either worked well or something that doesn't work well, please post that in on the mailing list. You might even subscribe with an anonymous account with a throwaway email address and post it there. But other users will benefit. They will read the mailing list, they will read the archive of the mailing list, and they can then build their knowledge on the experiences of people that came before them. All the source code for Kea is in the ISC GitLab, and there you can review the existing tickets. You can have a peek at the roadmap on new features being planned in the future. You can see the or you can even open a new ticket if you find something that is missing or something that is a bug. So defragmenting the network. People old enough like me might remember the time when we had to defragment our hard drives from time to time because they were getting slower and slower, and defragmenting them, the old spinning rust hard drives, made them a little bit faster. Now, same is kind of true for networks. If a network grows organically, that network tends to fragment, and that makes not the network slower necessarily, but it makes the administration of that network slower because it's more complicated than it needs to be. Also, a network that has been designed 30 years ago might not use all the new features that are available in modern networks, in modern network protocols and architectures, and knowledge that have been accumulated since the times. So try to declutter your network. Remove shared networks wherever possible. Shared networks where you had to split small IPv4 chunks because the IPv4 space was scarce and you couldn't move around at that point of time. Maybe now there is time, or maybe there is no space. And maybe you can remember parts, renumber parts of your network now and get rid of the shared networks where possible. Free up unused IPv4 space where possible. You might need to use that IPv4 space, or you could even, if it is public IPv4 space, even sell that IP space and make some money. An IP address management, an IPAM system, can be a great help by doing that. There are good open source ones like Netbox that we had in the last webinar in April. And there are also good closed source products that you can find. And maybe you already have one of these products in your networks. Use it. And an IP address management system can also a good way to update your documentation. And if you declutter your network, if you make changes, don't forget to update your documentation as well. Still on IPv4, maybe this is time to consider IPv6. Maybe there are networks that don't need IPv4 anymore. Don't be afraid to look into making a bigger step. Maybe instead of going dual stack, that is running IPv4 and IPv6 side by side, maybe in some networks, you can go all in with IPv6 and throw out IPv4 altogether. And by doing so, you get rid of legacy IPv4 isms like small networks. And maybe some of the networks that you have might be okay with automatic IP addressing that is available in IPv6, the stateless auto address configuration. And you might not need DHCP at all in these networks. That's probably not true for all your network segments and subnets that you have, but it might be true for some. and make yourself familiar with the new functions and features of Kea DHCP. There are many of them compared to ISC DHCP. And the recordings of this webinar series will help you with that. There might be some solutions that were difficult and complicated with the ISC DHCP that might now be much easier to implement because Kea has additional features. One area where ISC DHCP and Kea DHCP differ is the high availability. Where ISC DHCP just had one high availability function, Kea has multiple options that we can implement. So which should we implement? The next slides give some ideas. Now, every network is different, so we can't recommend you to use this and nothing else. It really depends on your network, but we hope that we give you some ideas what is possible and which high availability solution fits best to your networks. So there is the question whether you need load balancing or whether hot standby is a better option. Now with load balancing, both Kea nodes will be active at the same time and the load will be shared. That means if you have complex client classing roads that take up CPU cycles, such an environment might be faster in a load balancing situation because both Kea servers are active and both can share the load of network requests, but also load of evaluating the client classing rules. However, make still sure that if one of the high availability load balancing cluster fails, that the remaining server has enough CPU resources to process all the DHCP requests. The service might be a little bit slower in this case, in the failover case, but it should still be able to respond to all the requests coming in. And don't rely on thoughts, test the system. Try to come up with a test lab where you hammer your DHCP service with requests and then shut down one of the instances of the cluster and see if the other survives. One drawback of load balancing is that the load balancing requires a manual 50-50 split of the pools, and there's no rebalance in the Kea DHCP, which might be not optimal in some instances, depending on the size also of the pools you use in your networks. The hot standby mode is much simpler. You only have one active server, and there's only one active log file, which makes troubleshooting much easier because you only need to look at one server in one log file. If you have load balancing, then a request can be processed by either of the nodes. So you have to have both log files open and watch for any issues there. With hot standby, there's no split pools required, and it's easier in our experience to upgrade and update the Kea DHCP software, also the operating system software and hardware, because you start with the standby machine. You do the updates there, then you switch over to making the newly updated machine the active machine, and then you can do the update stuff on the remaining part. So if in doubt, use hot standby. We can operate Kea DHCP in a shared database setup where two or more Kea DHCP servers talk to the same database cluster in the backend. And that allows for a redundancy setup with more than two active DHCP servers. In such a shared database setup, there might be the possibility, even though that possibility is quite thin, that two clients might get the same IP address, offered the same IP address, not that they will get the same IP address acknowledged. So there's no danger that there is a duplicate IP address on the network. But what can happen is that both clients will get the offer for the same IP address. Only one will succeed, and the other will get a DHCP not acknowledged from the server and has to restart the DHCP process again. Now, in our experience, this doesn't happen very often, and it's not really a problem, but should be taken into account. However, writing to databases, especially if multiple servers writing concurrently to a lease database, is or can be a performance bottleneck. If you use the mem file lease database, which is not an SQL database, that always has a better performance compared to an SQL database. And the mem file is simpler to set up and to use. So recommendation here is use the high availability module in Kea with the mem file. That is the more simpler and more robust solution. And only if you really have the requirement to have more than two Kea cluster nodes running in high availability mode, then consider the shared database option. And then there's the option to create high availability purely on the configuration without any software support. And that is possible with split and shared pools. However, that only works with IPv6 and DHCP-v6. So these are, or maybe good options for IPv6 only networks, but most companies and networks still have some IPv4 somewhere. So the high availability module is more universal because it works both on DHCP-v4 and DHCP-v6, and then, of course, all the supported lease storage backends. Next, a few ideas on how to plan a migration. So plan for regressions. There will be most likely some hiccups in the process. Something will go wrong, some stuff that you haven't anticipated will appear. So it's good to have a way back. What we found is that some older non-standard clients might have relied on special fix-up that have been in ISC DHCP for a long, long time, maybe put into the code back in the 1990s. Now, at ISC, nobody knows whether these fix-ups are still needed. They are not needed by any modern operating systems or modern machines, but who knows? Sometimes there are machines that do DHCP that can't be upgraded for reasons, but they are still in use, and they still should be served by the DHCP server. If something like that happens to you, please inform ISC so that they know that there are still these systems out there and being in use, and that the fix-ups that have been in ISC DHCP for these older machines will then be implemented in Kea DHCP if possible. It's a good idea to make the switch from the old DHCP service to the new one with changing the configuration in the DHCP relay agents. So have the relay agents first point to the old infrastructure, which is the default, and it's how it is run today. And once your new infrastructure with Kea DHCP is ready, you switch over the IP address in the relay agent configuration, pointing to the new service. Now, if there's some regression and the DHCP service doesn't work as expected, you can always switch back to the ISC DHCP or the older DHCP service because that's still running and still there, and then you can investigate and solve the issue without pressure. Sometimes special filtering or client classing that has been migrated over from ISC DHCP to Kea is too complex or then too slow when implemented with the built-in Kea DHCP functions. If that happens, don't give up. This is the case where you might want to use the Kea DHCP hook libraries. And the hook libraries are a good way to implement custom processing of DHCP requests. And because the Kea DHCP hook libraries can be written in high-level languages, in fast languages, C, C++, but even in scripting languages, in Python or Shell or any other language, they can be made fast. So that is then the option to go if there are problems with performance. Not that that happens very often. It requires a large networks with a lot of requests and very special, maybe multiple thousand lines of special handling of client classing to reach these limits. There is the Kea Migration Assistant, which is a tool that can read an ISC DHCP configuration and then spit out a commented version of a Kea DHCP configuration that is almost a working configuration and contains most parts of the configuration of the ISC DHCP. And I say mostly and almost because it's not 100%. It can't be 100% because the functionalities between ISC DHCP and Kea DHCP are so different that not every configuration aspect of ISC DHCP can be migrated to Kea. However, Kea Migration Assistant is a great tool to get inspiration how a new Kea DHCP configuration could look like. It's not a easy, like just use the assistant and you end up with a working Kea DHCP. That can only happen in very simple configurations, but it's a great tool to get the ideas how the Kea DHCP configuration should look like. My experience here is to split the existing ISC DHCP configuration into smaller but complete single file configurations and then apply Kea Migration Assistants, because these smaller configurations are easier to understand and to reason about and to compare the output and also compare the actual results on the network when working with smaller configuration parts. Most of the time, that is possible because the configurations, they are modular and they handle specific portions of the network. And with that, you can isolate the specific portions of the network in their own little configuration files and migrate them one by one. And then test the resulting Kea configuration in the same small but complete configuration. Don't try to test a 1,000-line configuration file and try then to figure out where the regressions are. Better is to have smaller files, smaller configuration, easier to spot any problems there. And later, if you are sure that the configuration work as expected, you can merge them together to create then the larger final configuration. So a few ideas about the step-by-step migrations. I don't recommend that you change the DHCP configuration and server for your whole network in one flag day. That is seldom possible or even recommended. Better is to go step by step, maybe subnet by subnet, migrate one subnet at a time, do some tests, make sure that that subnet works as expected, and then tackle the next subnet. The configuration of the DHCP relay agents can be used to switch over between the old world and the new world. And if you use low leases, that is, if you reduce the lease times before the migration within the subnet on the old system, and then you switch over, you reduce the risk to have duplicate IP addresses. Because if you just migrate over the configuration, the new server will start up with an empty lease file. So the new server will not know which IP addresses are given out by the old server. As we will see, there is no a new tool that you can use that will also migrate the leases from ISC DHCP to Kea DHCP. And if you use that, then you don't risk any duplicate IP addresses. Still, it's a good idea to have low lease times, because then any changes that you might figure will propagate faster through the network, through the clients. Start with lower risk networks. Identify networks that have lower risk to have fatal issues when there is a regression. Examples are guest or Wi-Fi networks, some non-production networks. In most larger organizations, there are some of these networks where a failure in DHCP is not fatal. If you don't have IPv6 now, but you want to start with IPv6, then maybe start with the IPv6 networks and introduce IPv6 into your network alongside your DHCP migration. Also look out for networks which have a friendly, knowledgeable user base. Maybe people with IT knowledge that can help you troubleshoot DHCP issues, that know how to call ipconfig/all on Windows or IP address show on Linux or something like that. Or maybe create opt-in networks that already run the new DHCP configurations in wireless and have a different wireless SSID with the old configuration still running, and then users can switch between the old and the new world and can test drive the new world and see if there are any problems. IT department networks are a good candidate for this. So I already mentioned that there is now a new tool from ISC, the Kea MA, the Kea Migration Assistant Leases tool, which is a Python tool, which I will demo at the end of the webinar. Wish me luck. That can read in the lease file from an ISC DHCP and will write out the memfile lease database for Kea DHCP. So what you can do here is you can read out all the current leases in your ISC DHCP, migrate that over to Kea DHCP, start Kea with already a filled lease database, and you don't risk any duplicate IP addresses in your network. So here's some steps that I've done in the past in migrations. So we start with the old infrastructure. We have a couple of different networks. We have routers with relay agent, and we have a running ISC DHCP servers. First, we get some knowledge around Kea DHCP. We get some experience. We install Kea DHCP in a test network or maybe in a smaller production network for some weeks, and we run that in the smaller and low-risk network. While doing so, we test features that we will also use later in the larger production networks. So these test networks that we see is the installation that we see here on the upper right. There we have a Kea Stork installation that is being used to manage the Kea DHCP server. But none of the production networks, network 1, 2, 3, 4 that we see here, is using the Kea DHCP. It's just a closed test environment. Once we are confident with the test environment, we then write and test the Kea DHCP configuration. And then we configure the DHCP relays to forward the messages also to Kea, but still send the DHCP request also to the ISC DHCP. So every DHCP request that is being received by a relay agent is actually duplicated, One is being sent to ISC DHCP, the other one is sent to Kea DHCP. And then in the network, we block the responses coming from Kea DHCP to back to the client and to the relay agent. That can be done with Linux firewalls, with IP table, NF tables, eBPF, but Kea must be run in the UDP socket mode if that firewall is running on the Kea DHCP host. If the firewall is running on a separate machine that sits in between the Kea server and the relay agent, that works even in raw mode. And then you can inspect with TCP dump or Wireshark or similar tools the responses that come back from Kea DHCP and also the responses coming back from ISC DHCP, and you can compare the responses even to the binary level. And there you can make sure that Kea DHCP responds with the same data, with the same options, the same number of options, and the same data value content in the options. Also on this step, you would implement logging and monitoring on the Kea DHCP. And this is the picture here. So with the relay agent here in the wireless network, in network 4, we can and the requests are being simultaneously sent to ISC DHCP, which is still the in production machine, and to Kea DHCP, which is the testing machine. And we can, with that, test drive a Kea DHCP with real world traffic without exposing the new system already to production. If that is all working fine, and we are confident that the responses given from Kea DHCP are almost identical or identical enough for the clients, we define a timeline for the migration. We lower the lease and refresh times for on the ISC DHCP. For example, 1 hour DHCP refresh is safe for most devices, even old devices. And with modern operating systems, you can even go down to lease times low as 5 minutes. But be aware of some older machines, old like MS-DOS, Windows 95, QNX or something like that, which might be still around in industrial control units. They need larger values. 1 hour is usually good for them, but don't go too low with them. If in doubt, do your testing. And then we switch over to Kea DHCP, and we do that for one network, and we do that for a lower risk network first, and see if that works as expected. And if it does, then we can go on and switch the other networks one by one by changing the DHCP relay configuration. And if there's a regression somewhere, we can always switch back to ISC DHCP as long as that is still there with the existing configuration. And then at some point of time, we are done and we have switched all the networks, all the subnets to the new Kea DHCP service. We still keep the ISC DHCP running for a certain amount of time, and we monitor that old machine to see if it still receives any DHCP requests. And if it does, we have to hunt down these machines and have to check where these DHCP requests are coming from. And if we are certain and we see in our monitoring that no DHCP requests are coming towards the old server, then it's time to shut down the old server and the migration is finalized. So, and I'm also finished with this webinar so far. We have a few resources for you, We have a great collection of the good people at ISC have created a web page with a collection of resources for system administrators around the DHCP migration. And this is the one-stop big web page where you go and you find the links to the webinar series, you find the tools and general recommendations how to tackle the migration. We have here the links to the Kea Migration Assistant and the new Kea Migration Leases tool. Here, as promised, some monitoring tools for ISC DHCP and monitoring tools for ISC DHCP and tools for Kea DHCP. And before I jump into my little demo of the new tool, the next webinar in June is about the new dynamic templates in Kea. Exciting new stuff that we will have there, and we want to demonstrate for you. And after that webinar, we're going into a summer break, and we will probably come back with new topics in the second half of 2023. So let me switch over now to my terminal window. And you should now see my terminal. And on this terminal, I have the DHCP to Kea Python tool. And if we just execute that tool, it will give us a help information about the different switches we have. We can do a verbose conversion where the results, that is the Kea DHCP lease file, will also be printed to standard out. We can implement debug, and most importantly, we can change on the command line certain values for certain fields. For example, we can override certain fields. We can also set the expire time of the leases. So if you already have lowered down the leases on your ISC DHCP before using this tool, then the leases will only be like valid for an hour or even 5 minutes, which is not good because they are possibly already expired when they reach the Kea DHCP server. With this -E switch, you can give a new expire date, which will then be written into the newly created leases file for Kea DHCP. There are some examples down here how to use the tool, but the easiest you use the tool is you just point the tool towards a DHCP leases file. And what that will do is it will read that leases file and it will write out a new Kea leases file. So let's look what we have here. So the DHCPD.leases file, that was the input file. And the DHCPD-leases-Kea.csv file, that is the newly created file that now contains the Kea lease file. Let's have a look into the different file formats. So this is the format of the ISC DHCP lease file. It's more verbose. Every lease has its own block with its start and end time and client lead time, the binding state, the hardware address, the UID, and the client's host name. And because the lease file is always appended, it's the same lease and the same IP address can appear multiple times, as we see here. And the result is a little bit smaller. The CSV file is just the 3 lines. The first line is the header explaining the different fields. And then the second and third line, in my case here, is 1 line per lease. We have the IP address, the hardware address. We have the valid lifetime, 600 seconds in this case, the expire time, and certain fields, the subnet ID, the full qualified domain name forward and reverse, the host name, the state, and the user context. And this file we can then copy over into our Kea DHCP installation restart or start a Kea DHCP server, and Kea will load this lease file and will immediately know about all the leases that happens to be on the ISC DHCP server side. And I've tested this back to the ISC DHCP version 3.0.1, which was released in 2004. So it works at least back to then. I haven't tested ISC DHCP version 2 and version 1, which were from more than 20 years ago. If you have such an old ISC DHCP installation, I would recommend first to upgrade to at least version 3.0 or even version 4, and then apply the Kea migration assistance and the lease assistance. So now going back to the slides, and we look if we have any questions.